Hi guys, happy Thursday. Here is the lesson 3 for your notes packet. So this is on page 8 in your packet. We're going to leave off there. So I will fill it in. You can write it down as I'm filling it in, just as I would do normally if I were in class. Obviously, feel free to pause it at any point if you need it to slow down or do whatever you need to do in that case. So first thing, your learning target is going to be, I can explain the difference between experimental and theoretical probability. So we've been talking about all earlier this week. We just quizzed on it, and we even talked about it last week, what theoretical probability was. We've been calculating it. We've been talking about it, all of that stuff. So theoretical was what should happen when we do something. So the example used most of the time was if we flip a coin, 50% of the time it should land on heads, and the other 50% of the times it should land on tails. For example, if we flipped a coin 10 times, 5 times it should land on heads, 5 times it should land on tails. Theoretically, that's what should happen. That's what we've been calculating. Today we're going to talk about experimental probability, and that is kind of the opposite. That's what actually does happen. So if we flip a coin 10 times, theoretically, we should get 5 heads, 5 tails. But the experimental probability would be what actually happens. Do we get 6 tails and 5 heads or something like that? So experimental probability is what actually happened. And then the other thing we'll talk about is relative frequency, just a new vocab word, but going to be similar to what we've been doing. And that's going to be the percent of time a specific event happens. So we were calculating percents before. The relative frequently goes directly with experimental probability, figuring out how many times did it actually happen in the experiment. So we're going to look at this example here, some practice with relative frequency. So basically what happens is we've got some players playing some sort of game, and we're looking at how many of them won. So we've got 2 time frames. We've got the 10 a.m. to noon. So we know from 10 a.m. to noon, there were 213 players playing this game, and we know that 22 of them won. Now, we don't know exactly what game we're playing, but typically we look at, okay, when you play a game, you've got a 50% chance of winning, 50% chance of losing. So we'd expect half of these guys to win, half to lose. Okay, obviously that's not what happened. Only 22 of them ended up winning. So 22 of them ended up winning out of the 213 of them that were playing. So in order to get that fraction to a decimal, we would do 22 divided by 213. So if you don't have your calculator, pause this and go grab it. And with rounding, we're going to get 0.10, which is going to be times 100 to get 10%. So we know from 10 a.m. to noon, 10% of the players won, which means 90% lost. Okay, then looking at noon to 2 p.m., so it's a different time frame, there was 262 players, 36 of them won. So a little bit more, 36 out of 262. There's also more players. So to figure out that decimal, we're going to do 36 divided by 262. We get 0.14, which is 14%. So from there, we know 14% of them won. So at 10 a.m., 10% won. And at noon, 14% of them won. But over the whole day, so if I add all of these guys together, 213 played in the morning and 262 played in the afternoon. So 475 of them played total. 22 won in the morning plus 36 won in the afternoon. So 58 of them won total all day. So I can do 58 divided by 475. And figure out that 0.12 or 12% of them won all day long. Notice how it's not adding these two, so just be careful here that you didn't just add those up to kind of the average. So 12% of the players won throughout the day. That is relative frequency. We're finding the percent that won, that actually won in the experiment. So we're going to go through a couple of practice problems here. We've got about, I think like 10 or 11 practice problems we'll go through, and then you'll have work time today on the worksheet. There's a Google form for it and some IXL. So this first one says, Lily is sitting on a bench and notices that 3 out of the 15 men that walked by had a beard. So 15 men walked by her, 3 had a beard. So we want to find the experimental probability that the next man to walk by her has a beard. First, I'm going to turn this into a fraction. To type 3 out of 15 on my calculator, hit enter. To simplify it, I'm actually going to get 1 out of 5. A decimal, I'll do 1 divided by 5. And when you do that, you're going to get 0.2 or 0.20, however you want to write it. And to turn it to a percent, I'm going to multiply it by 100 and get 20%. So based on what she noticed, that 3 out of 15 had a beard, we're going to guess there's a 20% chance that the next guy to walk by her has a beard. All right, next we're talking about flipping a coin. So we've used this as an example a lot. So Liz flipped a coin 50 times. We've talked about theoretically 25 times should be heads and 25 times should be tails. But that's probably not what's going to happen. We now know that 35 times was heads and 15 times was tails. So theoretically, the coin should land heads up 50% of the time. That's what should happen. However, experimentally, what actually happened, it got heads 35 out of 50 times, which if I type that in on my calculator, I get 70%. So theoretically, we should get heads 50% of the time. But within this experiment, it happened 70% of the time. If you want to make a quick note here, experimental, is what we're talking about today, is what did happen or what actually happened. And then theoretical is what we have been talking about. That's what should happen. Or maybe what we would expect to happen. So once you've got everything filled in on page 8, flip it over. We're going to go through some examples here on page 9. So this says that they surveyed 100 people to figure out where they're going in an airport. So they found 22 went to city A, 42 to city B, and so on. We want to find the experimental probability that a person is going to city A. Just a quick note, theoretically, if there's 1, 2, 3, 4, 5 places, there is a 1 in 5 chance, or 20%, that they go to each of these cities. That's theoretical. But we're looking at experimental here to go to city A. So 22 people went to city A out of 100 people total. If I simplify that into a fraction, we're going to get 11 out of 50. 11 divided by 50 is 0.22, and times 100 is 22%, which means 22% of people went to city A. All right, another one here with flipping a coin. So we know Randy flips a coin 30 times, 12 times gets heads, 18 times gets tails. Theoretically, that's what should happen. 50% of the time should be heads, and 50% should be tails. But experimentally, heads happened 12 out of 30 times. If we wanted to simplify that, we could get 2/5. 2 divided by 5 is 0.4 times 100. We'll get 40%. So we thought it should happen 50% of the time, but in this case, it actually happened 40% of the time. All right, now we're going to make predictions, and this is where we have to cross multiply. We talked about this a little bit last week. We're going to continue with it today. We know to cross multiply it when it's asking you about a specific number. So this one says a band played encore at 2 of its last 4 shows. What do we think is going to happen for the next 14? So the way we set this up is line equals line. And the first line is going to be the information they gave us. So they said 2 out of 4 of its shows. And then they're asking us about 14 of the shows. So we're going to put a 14 here. Then we can cross multiply. So we do 2 times 14, which is 28, and 28 divided by 4. Obviously, 28 divided by 4 is not going to give us a nice number. Yes, it is. Hello, what am I saying? 28 divided by 4, we're going to get 7. I'm not going to edit that out. You're just going to know I made a mistake. 7. So we expect 7 of the next 14 shows to play encore. Or play an encore. Next, it says a coffee shop recently sold 8 drinks, and 2 of them were Americanos. So considering this, what do we think will happen with the next 20 drinks? So they're asking me about a certain situation, so that's how I know to do line equals line. My first one is going to be the information they gave us. So I know that there were 2 Americanos sold out of 8 total. This bottom number should always be bigger in this case. And they're asking us about 20 drinks. I'm going to put 20 here. Then I do 2 times 20 and get 40. And 40 divided by 8 and get 5. So out of the next 20 drinks, we think 5 are going to be Americanos based on this prediction. All right. Now we've got some dogs at the dog park. So there were 6 dogs. 2 were German Shepherds. Now that we know this, how do we think how many do we think will be German Shepherds out of the next 12? So 2 of them were German Shepherds out of the 6 total, but they want to know about 12. 2 times 12 is 24, and 24 divided by 6 is 4. So we would expect 4 to be German Shepherds. That's what we're expecting. We're not saying that's going to happen. We're just expecting that. Last one on this page, an ice cream shop had 4 out of the last 12. Chocolate, how do we think the next 15 will be? So 4 out of 12 were chocolate. What do we think about the next 15? We're going to do 4 times 15 and get 30. oh my gosh, not 30. Wow, the math is not mathing today. 4 times 15 and get 60. And 60 divided by 12 and get 5. So we expect 5 to be chocolate. All right, once you've got page 9 done, flip it over to page 10. We'll kind of cruise through this last one. So if you want to pause and try and do these last 4 problems on your own, go for it. If you want to stay with me, you can. Otherwise, pause it and just make sure you come back and check that you got the right answer. So this one, Harper's playing some cards or some darts. She sees that she gets a bullseye on 3 out of 12. What about if she did 16? So I would do 3 times 16 and get 48. And 48 divided by 12 and get 4. From a sample tray, 4 out of the 10 were strawberry. What about 20? I'd do 4 times 20, which is 80. And 80 divided by 10 would be 8. All right, and the last couple, this one's talking about keeping track of winners for this game. So kind of similar to the front. I don't think it's the exact same numbers, but they played 2 time frames. They've got this many players, this many winners. Then they've got the total, and then they have the percent of them that won. Kept track of the players and the winners for his game. Based on these results, how many winners should he expect if 300 were to play? So we know that 71 people won out of 416. What about if 300 played? So I do 71 times 416. And I actually, nope, not 416. 71 times 300. And at 21,300 divided by 416. And I get a decimal. I get 51.2. I'm going to round that because we're talking about people, and there's not half people. So I would expect about 51 to win his game if 300 people play. And the last one here is Amir and Marvin each flip a coin 50 times and record the results. So based on that, theoretically, what do we expect? So theoretically, 50% of the time, so 25 times they should get heads, and 25 times they should get tails. That's what we expect theoretically. Why might their results be different from the expected probability, or why than the theoretical probability? And we just know that it's not always 50-50 when you flip a coin. It should be. But it's not always. So once you've gotten all of your notes done, make sure you refer to the Google Doc to what you're supposed to be doing. You're going to do, not the Google Doc, Google Classroom. So page 11 needs to be done. There is a Google form for when you're done, and then you've got some IXL to work on. And then tomorrow there'll be some more directions for you on Google Classroom.